All right, guys. We're gonna be doing a surge test on 1,000 watt, 12 volts magnesign magnum, which indicates magnesign magnum 1012. So 1,000 watts, 12 volt. Let's see the surge capacity. You gotta watch the current and you gotta watch the power, which is the wattage. See how much you're gonna surge. So we have the upright freezer and the family refrigerator that has the freezer on the top and regular fridge that everybody has or own in their home houses or whatever place of living. So let's see. Then I plug in the rice cooker that takes approximately 500 to 700 watts. So all these things gonna surge at the same time. I want you to pay close attention to these areas right here. Watch towards this, the current. We want to test this LiPulS battery, which is the 12.8 volt 200 amp hour plus, to see if we can able to drive that. I don't have a big 12 volt inverter that goes up maybe 3 kilowatts or whatever, 2 kilowatts. The biggest I have is a 1212, which is a 12 volt 1200 watts. But I've done it on the previous test. I just want to make sure that this 1012 or this 1210, which is a 12 volts 1000 watts, is gonna do the job. Let's see if it's not gonna shut down the BMS or the inverter is gonna shut off. It's a low frequency anyway, made by Magnum. So top off the battery, and we're gonna disconnect the battery here from the power, and now we're gonna get the load plugged in, and the freezers and the rice cooker. Speaking about it, I gotta push the power on. So let's see if this inverter can survive to do that, unless we have to do on the next test with Magnum 1200 watts 12 volt with LiPulS 12.8 volt 200 amp plus. They sent us here by LiPulS. Stay tuned, like and subscribe, pay close attention. If you missed that, please rewind the video and replay it again. So I'm gonna be here to do this thing. We're sitting at 14.5, 14.6. Let's go. 5, 4, 3, 2. Oh, it's such 113, 120 amps. I don't know if you started loads. Did you see the wattage? So see, we went to 1500 watts on oh boy, look at this 126 amps. So I gotta drop something or else the fridge just disconnected because the compressor, it raves, and it took a lot of amps, and the freezer dropped. The upright freezer is running. The main refrigerator went down because this thing is designed to surge. See what it surges? It's almost like very close to 2 times the capacity that was designed for. And we saw about 1500 plus, and we are pulling, look at that, we are pulling that right now, 58 amps, 38.2 amps on a 12 volt and sitting at 13. Did you watch the power, the voltage? Do we have a sag? Tell me on your next video, on your comments below. I want you to see what happened here, these numbers here, the transition, what really happened. So we drop all the way to 3 hours if we run this load continuously for 3 hours if the machines didn't stop, or maybe the freezer don't cycle. So we're gonna go continuously what we have right now with the rice cooker. See, it's coming up. So 65 amps is a big deal on a 12 volt. This is the difference when you run a high voltage, mid voltage, and a low voltage. So the low voltage is the 12 volt. You pull in so much amps on the DC side. See, and look at how we're dropping 12.99 right now, 12.99. So if it was a 24 volts, divide this by 2. So you're gonna be talking about 32.5 amps. If a 48 volts, divide this by 4. So you're gonna be talking about 15, 16 amps. 15 point something, 16 and a change amps. So that's the efficiency when using a 48 volt instead of a 12 volt or 24 volt. 36 volts, you divide this by 3. You'll get a number right now. So I can give you the math on that thing, if you can bear with me. So 65 point, let's say 66 right now, right? Let's say 66 amps divided by 2, 6 divided by 2, that gives you 33 amps on 24 volts. So if we go 66 divided by 3, which is a 36 volts system, that will give you 22 amps if it's using a 32 or 36 volt system. Okay, so if you have 65 amps divided by 4, which is a 48 volts, we only got 16.25. That's the difference when we normally say 12 volts is convenient but not efficient, and using a bigger wires. I'm running 3/0, which is a 3-hot cable, which is a 81 millimeter metric system. Okay, so we would have a low amperage drawer here at a 48 volt, which is a 16.25. So this is the difference. Look at the percentage is dropping. So the freezer hasn't started yet. The refrigerator, the upright freezer is up, the rice cooker is on, which already maxed out this thing. The inverter is just about 1,000 watts. I would have used the other one, which is the 1200, that we can have a buffer zone. But stay tuned, watch this thing and see if we can able to trick that fridge to kick in. Well, it seems like it's on. I can hear it running. Maybe the compressor hasn't started. Maybe it's a fan. But let's pay close attention and see. We're putting 66 continuously. So 3 devices running simultaneously, and which is cool. Okay. So the most necessity, which is the refrigerator, your freezer, deep freezer, plus your rice cooker. So you can cook your rice and done with it and go back to your regular television, which doesn't pull anything. So see how the batteries are holding up here. But it's gonna be a one-hole controversy or one-hole argument if I try to compare lithium ion and lithium ion phosphate. To my experience, I don't know what other people, I'm speaking for myself. I'm not speaking for your household. I'm not speaking about your solar system, but to the equipment I'm running, my testing, I got it all. Okay, I have a low frequency, a high frequency. I have a high-end equipment. You guys have watched my videos. You've seen what I have: Outback, Magnums, and Victrons. You see, and you can tell me if we ran a lithium ion instead of lithium ion phosphate, we wouldn't drop this fast at all. Lithium ion tend to maintain. The voltage is not going anywhere. But what I've learned, I don't know for you, for me, I'm speaking for myself. It's my opinion, or it's a fact because I've proven it. You know, it has been proven. In my opinion, this is too much. If it was a lithium ion battery, this guy is not going anywhere. It should have dropped from that 14 to 12 point something. It's not possible. I would like to do this comparison when I have, because I discarded all my lithium ion batteries. I still have my Volkswagen e-Golf. I have them, but it's a 24 volt. I wish I was able to put them all back to 12 volts. Then we can do a comparison and see exactly what I'm talking about here. This voltage won't go won't sag all the way this. But lithium iron phosphate, LiFePO4s, they tend to sag for some reason. But if you watch some of the cars, the electric cars, they still have lithium ion batteries. They still have lithium ion batteries on them. But this is the deal, guys. I don't know what to tell you guys. This is a fact. This is what I've proven. This is what I've seen when it comes to lithium iron phosphates. They always drop. And I'm running a 3 hot cable, 3/0 metric is 81 millimeter square cable. It said we can maintain this load for 2 hours 31 minutes. And we already took 10 amps off from the battery, and look at what we're sitting at right now. We're testing the LIPULS, LIPULS, 12.8 volt, 200 amp hour plus. And it's taking the power on that one is 2560, 2560 watt hours. See how the percentage is kind of fluctuating there, but we are putting 65 and a change, almost 66. So it would have been a good less power we're going to be pulling on a 48 volts if we run a 48 volts. But the only disadvantage, you see, the advantage, you get a lesser amps coming out. You have a longer run time, it's efficient. If you're using an inverter that is efficient as well, and the wire is smaller, instead of using a big conductor like that 81 millimeters, too huge for 48 volts. Oversized is not a problem at all, but the higher the voltage, the more efficient it be, and more less power you take in. But the equipment are expensive. A 48 volts, when you cross 24 volts, they started getting expensive. 12 volt system, some people said it's expensive because you're buying single batteries. But now you can buy a 48 volt battery, just one single module. But the efficiency, the disadvantage over the, how am I going to say it? I forgot. The 24 volts, it's not that efficient, but it's convenient. Something goes off, you can find it at the store, you can find it somewhere else, you're able to replace it overnight. 24 volts, that goes a problem now. You gotta stop like a truck station or truck stop, or 48 volts, and those trucks don't run 48 volts at all. They run 24 volts. So this you have to wait. You have to order the parts and wait. You see? But this one locked into the $12.99.98 constantly. while the fan is running on the inverter. But we just want to focus only into this. Like we drop another percentage right here. See what I'm saying now? But 48 volts, small wires, efficient, longer run time, and it's easier on the equipment. They don't run constantly and they tend to last longer. 12 volts, they're gonna overheat because of higher amperage. Look at this. Divided by 4, you get whatever is on a 48 volt. And the cable is cheaper, you know, compared to the conductor is cheaper compared to what you can use on 12 volts. So if we take a 65.36 divided by 4, that gives us only 16.32. We would have run this battery for a long time on 200 amps. But now if it's on 12 volts, we have 4 batteries of those LIPULS. It's at 800 amps. That's a lot of power. Well, this is my comparison I want to make for you guys. 24 volts is in the sweet spot. No, it's not as bad as a 12 volt. It's much efficient more than a 12 volt. Though it still pull more. It's a half of this number. It would have been like 32 amps. See? But it's gonna be better. It's the sweet spot, 24 volts. 36 volts is just crazy, just in between, past the 24 volts, little bit. You know, look at this number, is falling. Percentage is falling gradually. And now I still see that 2 hours 27, it was 2 hours 31. And this is the power we already accumulated. Could you imagine running this continuous load? It's a small load for 24 volts. It's a small load for 48 volts. But this is all I have to show you guys. I've seen it all. I've tested all. My 12 volt inverters are all efficient. They are low frequencies. Magnesign Magnum. Look it up. 1012 or 1212. They even have the 1215s. Those are international. Okay. 230 volts, but it's running. That's all I have to say. And I would love to have to put 2 of the inverters, the 12 volt ones, on the same battery and see how much we can able to pull. Maybe 65 times times 2. If we use 2 inverters, we run the same thing, so we're gonna pull 130 amp. So if we put 3 inverters running on the same battery, I don't know if the BMS is gonna handle it. You know, 65 times 3 is 195. So I just want to do the test that LIPULS was talking about, saying you can pull 400 amps continuously for 30 to 31 minutes. I want to see that, but I don't have a bigger inverter to do that. Look at this. It's falling on a 12 volts. I don't think it's the battery that have the problem, but pulling a heavy current. Like and subscribe. JW Solar USA. I'll shut down the tea kettle, the rice cooker, and you'll see this number fall, and the amp's gonna drop as well. It might be the voltage gonna come up. There we go. We turn it off. We drop to 200. So that rice cooker was taking up to about 500, 550, something like that. So we jump from, we're going up. This number is going up now. So we're gaining hours now. It's going to 3 hours. Counting. Look at that. We're only pulling about 20 amps, which is the refrigerator and freezer running, upright freezer running simultaneously. We're gaining more hours here, and the wattage is lower now, the amperage is lower, and we gain more from $12.99 to $13.15. Yeah, that's all I have to show you guys. Like and subscribe. JW Solo USA. Thanks for watching.